Okay, we're going to look at higher order derivatives. So the idea here is finding a derivative beyond just the first derivative. So suppose we have y equals x cubed minus 5x squared plus 2. Pretty simple polynomial function. So if we were to find our first derivative, we know this will be 3x squared minus 10x. Our second derivative, once again, we're going to use our power rule. So we're going to have 6x minus 10. So this is read y double prime, y triple prime. So you can see the three little tick marks, that or the prime marks, that indicates a third derivative. So this is just going to be 6. Now we don't use those little prime marks beyond 3 because it just kind of would get messy looking. So instead we use in parentheses the number. So the fourth derivative, you can see y to the fourth like that in parentheses. Please understand, by the way, this is not equal to writing it as y to the fourth. Okay, so if we want the fourth derivative, we need to use parentheses. So that would be 0, and then the fifth derivative would be 0, and any subsequent derivative, of course, would still be 0 for this particular function. So another way of writing this out, for the first derivative, we say dy dx. For the second derivative, we would write it out in this manner, and notice the placement of the 2's. For the third derivative, it would look like that. For our fourth derivative, again, this is where we would make use of the parentheses. Okay, and you can do this for any generic number, which we can call n. Okay, so that's what it would look like if we're using that alternate notation. All right.